Hey everybody, welcome back. This is Isograms for skeleton section of Module 2. An isogram is a word that has no repeating letters, consecutive or non-consecutive. So we're going to write a function called isIsogram. And you pass a piece of text to it and it's going to tell you if it was an isogram. Same idea as we've been doing in the skeleton section. You're going to want to create your own test case, and we're going to. Give you a skeleton. You want to assume the empty string is an isogram, assume your input is only letters, and ignore case. This one's kind of important. Well, they're all kind of important, and most of these are designed to just give you extra things to worry about. But this one's kind of cool because it tells us about something called a set. And a set drops duplicate values. And so let's go over here to MDN, have a look at a set. The set object allows you to store unique values of any type, whether primitive values or object references. Okay, so it looks like we can create a set, say new set, and then pass in an array to it. And it's going to give, well, it'll be a set at that point. And there's some things that we can tell about a set. Some good reading here. Going to want to consider that at a certain point, we'll want to call this myset.size. So let's jump back over to our isograms page. We'll copy all of this, and we're going to put it in a replit. So function definition, let's get rid of this. Say empty string should return true. It's an edge case. It was like, hey, where'd it go? Assume the empty string is an isogram. That's fine. So if we get an empty string as the input text, we'll just return true. But now let's think about our assertion functions to be used. The isIsogram is going to return true in the event that we have an isogram, and false in the event that we don't. The return value for this is going to be a Boolean. If the return value is a Boolean, we're going to use assertEqual. So a function, assertEqual, is going to take in an actual value, an expected value, and a test name. It's going to compare if actual is strictly equal to the expected value. If it is, we're going to console.log. If we can never find the keys, passed. Otherwise, we are going to console.log our fun little message. It's always going to be failed. Plus the test name. We're going to put the test name in brackets. And we expected, right, it's there. Quotes around the expected value. Expected plus, there's the end quotes for that, comma, but got quotes plus actual plus the end quotes wrapped around the actual. Okay, now for our test cases. We want a couple of pieces of text that are going to either be isograms or not. So let's think of an isogram. We'll say variable pass1, or say isogram, we'll say actual pass, let's consider this. We're going to have a series of inputs. Some of them are going to pass, some of them are going to fail. So we'll say input pass 1, input pass 2, input fail 1, and input fail 2. Now our assumption for all of these is that we'll come up with them in a moment. So a passing input could be something like A, B, C, D, E, F, G. That's an isogram. Another one that could pass would be something like stop. That's an isogram. Now we need a failure one. So we'll do one failure which just has extra letters, or letters that are repeated. So we'll say stopped, because that has a repeated P, so this is not an isogram. Now we're going to want one where there aren't necessarily any repeated characters ordinarily, but they'll have once an uppercase version of another lowercase letter. So that according to our test cases, we want to ignore case. And so if we have something like A, Q, Z, R, P, J. Theoretically, A and A are not the same letter, but this is going to fail because we want our function to fail. So now that we have the input pass for and input fail for each one of these, we will, create test cases out of this. So we'll say actual pass1 is equal to Isisogram. We'll copy this so we can keep copying and pasting it with input pass1. Variable actual pass2 is equal to Isisogram called on input pass2. Variable actual fail 1 is equal to Isisogram on input fail 1. So this should fail because it has a repeated character. And I'll just copy this whole thing. Actual fail 2, input fail 2. So let's put some space in between these. And we need a call to assertEqual. So assertEqual, we're going to call in all three of these cases. Copy there, copy there, and last one there. So assertEqual is going to take our actual pass1. The expected value for that is of course true, and we'll say should return true for an isogram. And let's make a couple of these, we'll make it STOP with uppercase letters. So for an isogram, we'll say with all lowercase. We've got most of that, so let's just highlight the inside. Actual pass2 for true should return true for an isogram with mixed case. A lot of people ask, how do I know if I'm generating proper test cases? You don't. You'll know if you didn't because the code that you put into production fails on something that you should have tested it on. But in terms of proving that you've exhausted the search, that's actually relatively difficult. So practice makes perfect, and try to remember times when you messed it up. Like if you wrote a function and you tested it and found out that it didn't work later, try to remember instances where you failed, because you'll be able to remember those in future with a little bit more ease. So assertEqual, we want actual fail 1. We want it to come back as false, so it should return false for a non-isogram with lowercase. Let's say non-isogram with lowercase. And our last one will be input fail 2. Should return false for a non-isogram with mixed case. Could definitely entertain the idea that a good test case for this would be the empty string, but since we're going to do that as a edge case, it's not going to be necessary for us to test. By edge case, I mean the first thing we're going to do is we're going to say, hey, if text is equal to an empty string, just return true. So we know that's going to work. Now, add each character to a set. This one's tricky, right? Because what we have is we have what looks like something that we can add. Where is it at? We can add an array to this, and the array will give us a set. So where did it go? We'll say variable set of letters is equal to new set. And in here, we're going to want to pass some kind of array of letters. So we need an array of letters. We have text, which is a string. We know we could get array of letters if we call split on our text. We're going to call split with no parameters. And the idea here is that it's going to split it into each individual character. So now we have an array of characters, or an array of letters, and so we're going to pass that into set. Now, before we get too much further in this, set is a relatively new version or portion of JavaScript, so hopefully this will work. If it doesn't, there's always the possibility that the interpreter that you're working on doesn't work with set the way that we want you to. If that happens to be the case, that's just bad luck. And you might take the opportunity to learn about something called transpilers, which are fun. Transpilers are basically a way to take code written in newer versions of JavaScript and allow your website or your environment or whatever it is to, if necessary, translate it back into old versions of JavaScript. Something like that. Let's look it up. Transpilers. Transpiler for JS. Transpilers are source-to-source compilers, are tools that read source codes written in one primary language and produce the equivalent code in another. Okay, that's close enough. Note, a set drops duplicate values, thus check if all the characters were unique, check length of text and the size of the set. All right, so we're going to ask it if set of letters, our set, dot size is equal to our original array of letters dot length. To be sure, we could absolutely say text dot length. Because we're creating an array that's just going to be all of the characters in text, text and array of letters should have the same length. So if these are equal, this entire expression is going to be true, and we would know then we have an isogram because we're returning is isogram. So what I would say is let's just return this entire expression. Return set of letters dot size is equal to text dot length. So we've got a function is isogram. It splits up the input into an array, creates a set out of that array, which is going to drop duplicate values, and then it's going to return the size of the set versus the original text length. If this length is not the same as the size of the set, then we know we don't have an isogram. If it is, we know we do. We've got 4 handy-dandy test cases chilling in the bottom that we already wrote. We're going to get 2 passes and 2 fails, although to be sure, they're all going to say passed because we're comparing with true up here and with false down here. So with that in mind, let's go ahead and run our test. Oh boy, a colon where we should not have one. So eval machine on line 21 it looks like. We've got a colon where we should not have a colon. So if we scroll down line 21, we'll see that we wrote passed and then a colon instead of a semicolon. Once we adjust that, we'll hit run again. And it's not liking that. Unexpected token. Sweet. So whenever you see an invalid and unexpected token, what's usually happening is that it was expecting you to do something that you didn't. Namely, you're going to get these with curly braces sometimes, and very often it's you forgot something. You were supposed to write something and you didn't. And if we look at input fail, you can see that there is the beginning quote here. There is no end quote here before the semicolon that ends the line. So if we scroll on down to input fail 2, we see that we did forget that. So we'll put that in there now and run the code. Passed. Should return false for a non-isogram with mixed case. Expected false but got true. And so we've identified the thing that we forgot to do, which is if we are going to ensure that the text is independent of case, I would suggest that what we need to do is translate this to lowercase first before we start checking any isograms. Because obviously what happened is that it decided that A and uppercase A are different. So those occupied unique values in the set. We don't want that though. Our function needs to say that, hey, this is not an isogram because A is essentially the same as uppercase A. So what we'll need to do is we'll need to make sure that we change everything to lowercase first. Now, a couple of ways to do this. One is we're going to open up the console, which we haven't done in a while, but it's a nice thing to do. We're not going to worry about all that by hitting Command K, and it's going to clear it. And what I'm going to write is a quick test of lowercase. I'm going to say variable text is equal to, why don't we just make it the one that we're trying to do? We'll make it this one. Oh boy, back up. So we'll say text is equal to that. Now we're going to say text is equal to text.toLowerCase. We're going to call that, and we'll see what text is. Cool, so that works. So what we need to do is we need to say text is equal to text.toLowerCase, and that's going to make sure that all of the letters get changed to lowercase versions so that we can compare them the way that we want to. So now that we've done that, we're going to accidentally hit save, because it doesn't actually do anything here. You can hit save, you can sign up and log in and keep these. It's a very, very good website for a lot of things. Of course, I'm not because, laziness or something like that. But anyway, if that's something you are interested in, absolutely feel free to do this. There's also a multiplayer mode and a share. Can't really say enough good things about Replit. It's a great website. They also were very kind to us at Hack Reactor and let us use Replit for a long time when they really didn't have to. So can't really say enough good things about Replit. Anyway, now that we've got that adjusted, hopefully this is going to sort things out for us. So let's hit run and see what we got. And we passed. Everything's in good shape. So let's go over here, highlight everything, copy it, come back over to the input window, paste it on in, have another look at the code because it's just so nice and fancy. And we'll come back here and submit or run the tests, and we're correct. Thanks for watching. I hope you're enjoying these videos, and we'll see you in the next one.